Thank you. Um, my name is Mike. I just returned from a holiday, so if I'm still a bit rusty for the next 25 minutes, it's because I'm like 50% still in holiday mode. Today I'd like to talk a bit about layered architecture. I find that this topic very well resonates with people or teams that create apps that are not bad. So what does this mean? They create apps that do everything they should do, they do everything that they must. Oh, iets omhoog. Is this better? The apps they do everything that they must do, but then someone comes along and says like, okay, now we have to add this tiny one little thing, and then it feels like open heart surgery on your app. Your application it's a bit risky. People feel that they hesitate to touch it. This will take 6 sprints, and they're like, why? What? This is a small feature. So people they're a bit afraid that modifying your code might trigger some unintended side effects. Other symptoms of like an okay app is that everything works, but I spend a lot of time scrolling through all of my code, like finding stuff, understanding stuff. Where does this start? Where does this end? Other symptoms are like functions that do everything. So you have one huge big function of several hundred lines, 10 plus parameters. Tests, we don't do tests here because it's very difficult to test code like this. We have to spin up a database, manually insert records and clean them up afterwards. And we have, for example, people who we rely on very much. Those are the people who just know the code base. You need them. They have this tribal knowledge of, this is where you need to look and just fix this and that. You're not really confident when you deploy your application. So this is kind of like the problem we're trying to solve. The apps are brittle. They still deliver value, but the structure is unclear. The responsibilities are blurred. A small change feels disproportionately expensive. So this is what we're trying to solve today. So the goal of this talk, I find that layering your app helps, but layering is not a classification problem. So what we're not trying to do is create a perfect categorization, like debating whether a piece of code belongs in this layer or this layer is not our goal. That completely misses the point. Our goal is to create apps that are readable, robust, and extensible. Readable makes them more understandable, easy to navigate and find the piece you need. Robust, so you can test your code. It's able to survive change at the edges. And extensible is like you can add new stuff to your code. You can evolve it, and this is a measure of how risky it is to modify your app. So all in all, we're trying to apply the principles of loosely coupled layers of responsibility. Little disclaimer first. What follows is not an exact recipe. So I'm inspired by all kinds of things like domain-driven design and solid and onion design, hexagonal architecture, stuff like this. But my focus here is to show the principles, inspire, and use these principles for your own situation and create something that works for you. I would say like no strategy is always worse than a bad strategy, so pick something and start layering. First, a little bit about me, who you're talking to or who you're looking at. My name is Mike, I'm 36, I live near Groningen. I've worked with data in the past 10 plus years. Professionally, I like making data work for organizations. I like to turn data into something that helps you. It should help organizations instead of be a risk or a detriment. So I'm focusing on turning data from a risk into an asset that the organization can use to achieve their goals. I do this from a technical perspective, technical standpoint with experience in data platforms, data engineering and system architecture mainly, but I strongly believe that the best results come from combining technology with organization, business, and teams. That way you can create real impact and change through solutions that really get used. So what this looks like is I've built and scaled all kinds of applications, teams, departments. Currently I work at Soprasteria, where we've kickstarted the data and AI practice. We're always looking for people, so if you're interested, come talk to me. Currently, this is Soprasteria, and currently I'm a data manager at Instituut Mijnbouwschade Groningen via Soprasteria. And in my free time I also have some hobbies still. I like to write about my coding adventures, all kinds of subjects. I've been doing this for a little over 5 years now, 100 plus articles and a lot of views, so come and check out mikehuls.com. I'm also published on Substack and Medium and towards data science, but everything on there is free. So if you're interested, check it out. The layers, that's what we're here for. First we'll check out which layers there are, how they relate to each other, and then we see how you use them in a practical example. So let's get started. These are the layers. There are 5. These are the layers that I use, at least. All have their own responsibility and their own relationship towards one another. Let's start with the inputs and outputs. Oh yeah, by the way, this is how your entire repo should be organized. So this is one repository that gets split up into these layers. So we have some code for the interface, and the interface is like the entry point for your application. So this is how the outside world calls your application. You might think of things like an API endpoint, for example. The right side, the right side is how your application talks to the outside world. So these are the infrastructure and the repository layers. We'll get a bit more about how what they exactly do, but just know that this is like the input for your app and the output. Next, we have some additional rules, how the layers relate to one another. So as we see that, as said, dependencies flow inwards. The arrows, they indicate the control throughout the application. You see that, for example, the interface can call upon functions in the application layer. The application layer can use things from the domain. And the application layer also can use functions that are on infrastructure and repository. So the application layer is kind of where the magic happens. And we see that as well when we go through the responsibilities of each layer. The application layer is like the heart of your system. I believe that every application should solve a business problem, and this is where that happens. This is where all the business logic is, and this is where everything comes together. So the application layer is the heart of the system. It coordinates, and it uses all the other layers. For example, the interface layer. You can see, for example, here that's an API endpoint. Imagine where Booking.com or Airbnb, your front end might call a function on this layer to get into our system, to trigger something. I usually keep this layer pretty thin and void of business logic, because that's mostly in the application layer. The main responsibilities are just receive input, structure it, validate it, call something on the app layer, wait for a response, format the response, and turn it back. So it's mostly like a sentinel function, like data comes in, data comes out. Next is the infrastructure. I think of this as tools for your application. So think about things like logging setup, hashing and crypto utilities. No business logic here as well. Your application layer should use functions that are in here as a way to just, as a sort of toolbox kind of. For example, we have a send email function maybe. Your application layer doesn't need to know how SMTP is implemented or what happens in that function. It just should know how to call it. So in that way, it's loosely coupled to it. Other examples are, for example, message queue clients, HTTP clients for other APIs, etc. The next is the repository layer, and this kind of resembles the infrastructure layer, only it specializes on persistence. So think about ORM models, database schemas, SQL queries, persistent-related transformations, stuff like that. The application layer should not be responsible for knowing which database we use, how queries are written, or whether data comes from SQL or some cache or some other service. It just needs to call a function, get customer, provided with a customer ID, and it gets returned a customer object, or nothing, or an error. This way we can decouple our application layer from our database. So for example, if you want to switch out your database or put a cache in between, you don't have to modify any business logic in your application layer. This is the domain layer. This mostly is about constraints and definitions. So I mostly put Pydantic models here. This defines what the data looks like that flows through your system, and is very important, to me at least. I usually keep this very strict and fail early, because this determines what quality the data is that flows through your system. An example is, for example, the user. Imagine we're Airbnb again, and we want to define what a user looks like, what attributes it has. So it must have a name, an age, and telephone number, and address, for example. A definition of what your data should look like. A useful side effect is that this might create a shared language between the engineers and the business people, so to say. So non-technical people will not be required to read this line by line, but they instead understand the structure and intent. So they know, okay, this is what a user should look like. In my opinion, the closer you are to the business, because every application is solving a business problem, the more you can connect with your business users, the better your solution will be. So this is a very nice way to contribute to that. So, a very quick example about how this looks, what this looks like in practice. Imagine we're Airbnb again. We need to register as a host, because I have a house, I would like to put it on Airbnb. So our front end, I type in some stuff. This is my name, this is my address and stuff. Now I call a route on my interface layer. This is like fast API. It receives the information, validates it, okay, check. I call a application function, for example, the create host function. The first thing this does is create a host instance from the host class. Checks out if all the validations are correct, is the phone number in the right format, stuff like that. Next, we provided an email address as well. We can use that in the check email function that's part of our infrastructure layer. This will, for example, perform some regex or check out the domain for stuff like this. If everything is all right, we insert new host using a repository function, and if everything goes well, the application layer returns to the infrastructure layer or the interface layer, and the response is returned. So, little recap, how does layering help me? We focus on separating responsibilities, and for this we follow some rules. How the layers communicate with each other, stuff like this. These rules make development a bit less flexible, but that's a small price to pay for the benefits it offers, because our data, our repo will become more readable. You know where to look for a certain piece of code, which also helps with onboarding new coworkers, in my experience. Also, while developing, you reduce cognitive load. You don't have to think as much and search for stuff. So your app becomes a bit more understandable, not only to developers, but also to business people who you can work with a bit closer, ideally. Your app will become much more maintainable. For example, in the repository function, you can switch out your database and only have to change some repository functions. You don't have to perform open heart surgery on your business logic again. There's much more structure to your app. You know where the data comes in, where the data goes out, and where the boundaries are between the layers. And in my experience, I also focus a bit more on validation, because you have much clearer boundaries between where data comes in and how it flows through. And most importantly, your app becomes more evolvable, so you can add features on top of your existing code instead of modifying your existing code, which is a bit more risky. How to start layering? Thankfully, it's very easy to start. It's not something that you can must do or do not. You can start a little bit. For example, you can isolate out all the infrastructure functions. These are pretty well recognizable because they are void of business logic. You don't fail if you don't commit all the way, so you don't have to restructure your entire app before continuing. You can do it as you go. A simple example folder structure, you can create something like that and just start dragging files or refactoring code, moving it to other files. This will be a bit uncomfortable maybe, because you find things like, hey, where does this function go? It's a bit of this and a bit of this. And maybe that's a clear indicator that your function has too much responsibility. Maybe that's a nice signal to refactor it. For example, you do some stuff in the database, but also with business logic, maybe. Start small, add tests as much as possible. Testable data, testable code is always good. I tend to focus on validation and failing early a lot. Think about the edges, like where does my data come in and where does it leave your system? And where does one data go from one layer to another? That's, in my opinion, a nice way to get started. We've talked about layering within small apps. That's pretty understandable, but as apps grow, they can simply often collapse into God modules. That's not what we want, because engineers are smart and they will take shortcuts, especially when under time constraints. And we want to avoid our layers to become dumping grounds where you just dump everything in. So therefore we can slice up our application vertically as well, instead of just layering horizontally. In our Airbnb example, for example, we can check out several slices. We can layer for the host slice, the marketing, and the payment slice. So this way you can even structure larger applications in order to keep them maintainable. This looks like this in Airbnb. For example, we have our main application, and it's kind of like a sub-application, sub-module. You can call something on your host, like, okay, and create a new host, and then Airbnb gets returned, stuff like this. The other benefit here is that the host team can work simultaneously with the payments team, for example, because they don't rely on one another. As long as their interfaces are respected, you can work simultaneously. So horizontal layering, that's what we've talked about in the beginning, that improves structure, and this vertical slicing improves scalability. This is all pretty nice, but how do you keep your code intact, and how do you prevent it from drifting back to hidden coupling or circular dependencies, domain logic leaking across borders? For this I have like a few rules that I use myself. I don't follow them really strictly. The value is more in constant application instead of like strict reinforcement. So they're all pretty logical when you think about it. Do not import each other's internals. For example, if you're working on the host slice and you need like the definition from what is a guest, your guest module, and you're on the time pressure, it's really easy just to import it from the guests submodule and just go about your ways. But you can see that now, whereas first they were independent of each other, now they're pretty dependent again. Not what we want. The fix for this is to put shared concepts in a shared domain. The shared domain, however, must be small and stable and mostly contain definitions. So, for example, a shared module that contains all definitions for a host or a guest or something like this that gets used in several slices, that's okay in my opinion. And it should change really slowly, so because a lot of stuff on your app depends on this. Last rule, dependencies flow inward. Yeah, like the main function. In the bottom right, if you have I don't know, a repository function, something to do with your database that calls upon a function in your interface layer, something goes wrong. In essence, respect the rules. And that way we can keep our apps clean. So we can swap interfaces, infrastructure, test logic in isolation, and this will make our business logic survive change. In conclusion, layering. This is a very nice picture because it's first messy and now we've layered it nicely. So really fitting, I think. Layered design is not about adding ceremony or changing a textbook ideal. It's about understanding your system, ensuring your system remains understandable and adaptable as it grows. So we separate responsibilities and keep layers loosely coupled. This might at first seem like double work, unnecessary overhead, but as complexity increases, the payoff becomes really clear. We have changes become safer, testing becomes cheaper, and teams move faster with greater confidence. So the system remains stable. Ultimately, a well-layered application makes change cheaper, and in the long run, that's what keeps software useful. And with that, we've reached the end of this talk. Thank you for your attention, and I'll take some questions if we have time left.